Hello, everybody, and welcome back to another episode of the Bitcoin Blueprint podcast with your host, Stephan Zimmermann. I want to thank you guys so much for taking the time to listen in today. And on today's episode, it's a continuation of our series as we understand or get to understand Bitcoin and how it works. In the first episode, we covered what Bitcoin is and why it's important. And then in the previous episode, we talked about the different technological concepts around Bitcoin and how they work. Now, this episode is a bit more of a deep dive into one of those technological areas, and that is Bitcoin's peer-to-peer network. So in today's episode, we will dive into exactly how Bitcoin's peer-to-peer network works, what are the differences between a peer-to-peer network and more traditional networks, and the importance that it plays in the entire system. So I hope you're excited for this episode, and let's dig in. So I like to start every episode, or I think it's been a common theme in these episodes, that I like to start off with kind of a broad overview of the topic at hand. And so in this episode, we'll be talking about networks. And to understand really what a network is simply a group of interconnected things that communicate with each other to share information, resources, or services. So again, it's just a way to share data, in a sense, to other people through the internet. And in computer science, there's two main types of networks. You have what are called centralized networks, and then you have decentralized networks. Now, centralized networks typically have a name, or a model, which is called the client-server model. And to picture this, how a client-server model works is you have the server, and the server is essentially the server which houses all of the network's data. And then you have the client, which is what pulls information from the server. And so that's how most networks nowadays are actually set up, where what you see, for example, on a web browser or a phone, you're not actually holding the data that you typically see via an app or a website. You're not hosting that data yourself. Instead, what you're doing is you're connecting to some type of server, and then that server is feeding information to you, so to the client. And that's how most traditional, centralized networks are set up. And this has a lot of benefits, right? It's very efficient a lot of times and can be, very useful in a lot of cases. But then there's also cases where you would want a decentralized network. And this is where a peer-to-peer network comes into play. And essentially, in a decentralized or a peer-to-peer network, instead of having this centralized server, which holds all the data, and then the client, which pulls the requests or the data from the server, you have what are called nodes or peers in a network that act as both the client and as a server. So the way to view this is, again, in a client-server model, you're pulling data from a centralized server and then viewing that data on a client. But in a peer-to-peer network, you are both the client and the server. So you actually have a copy of all the data and then are able to view that as well. Additionally, in a peer-to-peer network, all peers are typically equal, meaning there's no hierarchical structure, and any peer can provide and request resources. And because every peer has a copy of the data, that means that the data is widely distributed across the network. So the main difference between a centralized network and a decentralized network is really where the data is housed. Is it located in a centralized server, Or is it decentralized and does everybody have access to it? And there's multiple pros and cons to each, type of network. But the main, real difference is that a centralized network often provides a single point of failure, because if the central server goes down, then everybody in the network loses access to the data and the network essentially becomes useless. We've all probably experienced this before. If a website, let's say, or an app like Instagram, when it goes down, everybody who wants to use the app, so Instagram in this case, loses access to the data. And that's because the central server, in this case, would go down and is unable to relay that information to the client. Whereas with a decentralized network, because the data is distributed across different peers in the network, even if one peer goes down, that doesn't mean that the network goes down. It means that it's still, hosted on a host of other peers throughout the network. And this really makes it much stronger and more resilient, which is very important, especially when it comes to a blockchain like Bitcoin and when it comes to money. So those are the main premises that you really need to know when it comes to networks and the differences between a decentralized and a centralized network. And if you understand that concept, it's easier to transition into Bitcoin's network, which is a decentralized peer-to-peer network. And in Bitcoin's peer-to-peer network, you have what are called Bitcoin nodes. You'll hear this term pretty often in the Bitcoin space once you kind of get into it more and learn a bit more. But essentially, if you hear the term Bitcoin node, that means that they are a peer in the decentralized network, which is Bitcoin. And now you may be asking, well, what are Bitcoin nodes? And essentially, Bitcoin nodes are computers that participate in the Bitcoin network by maintaining a copy of the blockchain, verifying transactions, and relaying information to other nodes. Each node in the network acts as a sort of watchdog, ensuring that every transaction adheres to the network's consensus rules. Now, in the Bitcoin network, you have a few different types of nodes, but the main two ones of importance, I think, are full nodes and mining nodes. And now a full node is kind of what we talked about earlier. A full node essentially maintains a complete copy of the blockchain. It validates transactions in blocks. It serves to enforce Bitcoin's consensus rules. And it also serves as a relay point to propagate transactions and blocks to other nodes in the network. Then you have a mining node. And a mining node is a full node. So it does everything that I just mentioned that a full node does. But then in addition to everything that a full node does, it also serves to compete to solve these complex mathematical problems to add new blocks to the blockchain. And there will be an episode coming up where I will dive a bit deeper or do a full deep dive into Bitcoin mining. And then we'll discuss more about how Bitcoin mining nodes work and the different areas of Bitcoin mining. But right now, it's just important to really understand that you have two main types of nodes. You have a full node, which maintains a copy of the blockchain. And then you have mining nodes, which also does this. But then in addition to this, it serves to add new blocks into the blockchain. So to kind of recap what we discussed so far, we talked about networks. And then we talked about decentralized versus centralized networks, where centralized networks house the data in a centralized server and then relay that information to clients. And then you have a peer-to-peer network where all of the peers or nodes in the network host the data themselves and so serve as both the client and the server. And then within Bitcoin, so Bitcoin is a peer-to-peer network, so it's a decentralized peer-to-peer network. And in Bitcoin, you have two main types, which are full nodes and mining nodes. But for the sake of this podcast, what we'll talk mainly about are the full nodes. in respect to Bitcoin and Bitcoin's peer-to-peer network, I think it's very important to learn about this concept and even to go about running your own node, because the beauty behind it is that because it's a peer-to-peer network and you're able to download the blockchain yourself, you're actually able to verify the state of transactions and also see that your balances that are reflected in your wallet are actually the balances that are reflected on the blockchain, because instead of syncing with a centralized data server, which you never really know if it's, unlaying the full data sets, essentially, with a peer-to-peer network, you can verify the full data yourself. So a way to visualize this or understand this a bit better is, let's go back to our classic example of a bank. And in a bank, how everybody is used to it is when you have money on a bank, you typically have access to an app or some type of a website where you're able to see all of your balances, your different accounts, if you have stocks, all of that stuff. But all of that data, so all of the data that you're seeing is stored in a centralized server that the bank typically hosts. So this is going back to the traditional client-server model. When you're viewing your balances on, an app or a website that the bank provides, you're a client and you're pulling data from a centralized server. So you're viewing the balances that are stored on a centralized server. Now, this can be efficient in a lot of ways, but the thing is, you have no control over the data that you're essentially pulling from, and you don't know what is being revealed to you. For example, when you're pulling data from a bank, it'll show your balance, but there's no way to, for example, verify that your balance that they're stating there is actually housed in a bank. In fact, most of the time it's not, because banks, what they do is when you deposit money into a bank, they typically rehypothecate that money, meaning they lend it back out. So they'll lend it out to, people looking for loans. They'll make investments with that money. So a lot of times the money that you're giving to a bank, sure, it'll show your balance on the website, but it's not actually housed in the bank. They're just showing, okay, you deposited this much, and this is how much, is in your account. And this is because banks oftentimes operate on what is called a fractional reserve system, meaning that banks actually only have to have a fraction of what is on their, what they owe to customers in reserves. And the rest, they are able to rehypothecate and try to make money off of the investments or the deposits that you invest into the bank. Because at the end of the day, banks are businesses, right? They have to make money. They have to, create some type of return on their investment. And that's why oftentimes, saving accounts and otherwise offer some type of interest rate, which is a form of a return that you are getting for putting the money on the bank. But that interest rate or that return that you're typically getting on a savings account, it's not free money, right? The bank doesn't just say, "Oh, thanks for trusting us with, putting your money here. Here's 3% a year." It's never that high, but let's just say, "Here's 3% a year. Thanks for being our loyal customer." No, what they do is they try to, make a return that is larger than whatever is, the interest rate that they are stating on your checking or savings account or whatever that may be. And they do this through giving out loans, through giving out, to making different investments. And so that's why when you're pulling this data from their centralized server or database, there's no way for you to really verify that, the balance that you're seeing, what is being done with my money, where is it going, anything like that. All you're seeing is what the bank wants you to see, which is, okay, this is how much you have deposited into the bank, so this is how much we owe you. However, in history, we've seen many, many cases where banks go bankrupt due to their unwise investment decisions, lose investors' money, and then are unable to repay the deposits that they have on the bank. And again, this is because it all goes back to the system that you're in. What are you incentivized to do? If you're incentivized to rehypothecate that money and try to make the largest return on your investment and generate revenue for a bank, then you're going to do that, but you risk losing your depositors' funds. And you don't have to go far back into history to see examples of this. Actually, most recently, and this is in September of 2022, there was a number of bank robberies in Lebanon. But the difference is that these bank robberies weren't people that didn't have money at the bank who were just looking to get money out of it. It was actually people who had money in the bank but weren't able to get it out, that they had to rob a bank to get their own money out of it. And one of the young women that made the headline is, she was an interior decorator, and she held up a bank in Beirut using what turned out to be a fake gun to withdraw her family's savings for the treatment of her cancer-stricken sister, since the savings had been frozen by the bank. And so, it's just a systematic issue where when you put your money onto a bank, you're never able to really verify if it's there, what they do with your money, how they rehypothecate it. And so it all comes back to transparency. And, we could have a whole episode going into the different bankruptcy crises throughout the world and history and examples of banks losing depositors' funds. But of course, this is an episode about the Bitcoin network. And so I want to keep it high level, but the important thing is transparency. And that's what a decentralized peer-to-peer network provides. Instead of having to trust what the bank is showing you, that that's legit and that you do have that money on a bank, which, don't get me wrong, oftentimes you do. And it's not every day that a bank goes bankrupt, of course not. But there's always that risk. And transparency at least provides you the relief that you're able to see certain things and be aware of the risk that is being taken. Because, of course, when you deposit money into a bank, there's a certain amount of risk that you assume, because it's not that they're doing illegal things. Fractional reserve banking is a legal system, but a lot of times people don't really know, and there's no type of transparency either a lot of times with the investments that are being made. And in a decentralized peer-to-peer network, you don't have this issue, because you yourself are able to download the blockchain and verify that the balance that you have, that you see on your wallet, is the balance that is indeed noted on the blockchain. And that, in my opinion, is a fundamental innovation, and also why I think it's very cool to run a Bitcoin node. And in addition to this added, transparency that you get through running a Bitcoin node, because a lot of times, and even in Bitcoin you have this, what you do is typically if you, have a wallet and you don't have your own node, typically what that wallet software does is it kind of goes back to the traditional model where that client, that wallet that you are using connects to someone else's node. And that node is part of the, peer-to-peer network. So a lot of times, of course, the balances that it's stating, it's true and it's verifiable, but you're still connecting to someone else's server in the network. So that's why, for me personally, I decided to run a Bitcoin node, because I myself wanted to be able to verify the state of transactions. I wanted to verify that the balance that I have on my wallet is indeed the balance that is on the blockchain. And there's also an element of privacy associated with it, because if you're connecting to someone else's node, say you have a wallet software that connects to a different node in the network, you're losing a bit of a privacy element as well. And of course, this all comes back to weighing pros and cons and, deciding for yourself if that's important to you, if you want that privacy. But for me, it's not a hard thing to do. And one, it gives me the privacy and verifiability and transparency into the blockchain. But also, being a node in the network is really cool because you're participating in the network, you're making it more decentralized, and you're able to, enforce and keep strong Bitcoin's consensus rules. So all those things make running a node very important, interesting, and useful, in my opinion. And because it's an open and decentralized network, you're actually able to track, how many nodes there are currently in the network. And there's this really useful website. It's called Clark Moody's Dashboard. So bitcoin.clarkmoody.com/dashboard. And it's something I use to not only look at the price, so it'll show you the price, but it gives you a host of other statistics when it comes to Bitcoin. So it's really interesting. But one of the statistics that it has on there is it actually shows you the amount of reachable Bitcoin nodes. And currently in the network, there's about 16,000, give or take. And that's interesting because there's only it's quite a bit, it's pretty decentralized and extensive. And, this doesn't, of course, take into account the mining nodes, but the reachable Bitcoin nodes are 16,000, which means if you run a Bitcoin node, you're one of the 16,000 people in the world that has a Bitcoin node. And I think that's very unique and cool. And, and I think there's a lot of people who, especially in Bitcoin, who run multiple nodes. So the number is probably even smaller. But being part of, this innovation in the beginning, I think is really cool because I know that as the technology develops, as more people get into the space, there will be more developments around nodes, and it will become more and more easy for people to run nodes and to verify the state of transactions and have a copy of the blockchain themselves. But right now, there's about 16,000 nodes in the network. Now, you may be wondering, well, Stephan, this sounds great. You're really pitching us on the node idea. And it's because I want to, because again, I think it comes back to the value proposition of Bitcoin, right? Being able to verify everything yourself. I think there's fundamental power in that, returning power to the individual rather than, big corporations who house your data and are able to see everything you do. Host a Bitcoin node yourself and take ownership over your Bitcoin stack. Be able to see it yourself, be able to verify it yourself. It's fundamentally very cool. And so now you may be wondering, well, this sounds great, but how do I run a Bitcoin node? How do I become a peer in the network? And I'll give you a high-level overview of, how it works in general. But there's a bunch of great tutorials on YouTube that show you, step by step how to do it. But essentially what you'll need when you want to run a Bitcoin node is you'll need a computer or some type of, computing device. So you can either, have an old laptop, and there's a lot of old used laptops that I think, there's people who are vouching, for example, for Lenovo ThinkPads that you can get used for, between $100 and $200 or euros. So you can get something like that. It doesn't have to be, a high-end computer. Or you can get a dedicated device like a Raspberry Pi, which is personally what I have. But the main point is you typically want it to be a dedicated device that serves just as that purpose to run a node. And so in my case, what I did is I bought a Raspberry Pi. And then what you'll also need is you'll need a external solid state drive because when you're downloading, essentially when you're running a node, you're again downloading a copy of the blockchain. And right now the size of the blockchain is around 576 gigabytes. So what I have is a terabyte solid state drive because I know that will, last quite a bit. And this 576 gigabytes is the total, blockchain. So going back from block one, you're essentially downloading the list of all the transactions that ever occurred in the Bitcoin network. And so those are the main two things you need. You need a computer, a dedicated computer or computing device, such as a Raspberry Pi. And then you need an external solid state drive or hard drive to download to be able to store the blockchain. And so once you have this, there's different implementations or different ways to, download the blockchain. The most common one, or the most, original one, I guess, is going to the Bitcoin website and actually downloading Bitcoin Core. And that's how it used to be done in the early days. You would go to the Bitcoin website, download Bitcoin Core, and then that would download a copy of the blockchain. And then you would have some other type of wallet software that you could then connect to Bitcoin Core. And essentially then you would be synced up. But that could tend to be pretty difficult because it requires a bit more advanced knowledge in how to run, a terminal, for example, and communicate with Bitcoin Core. I mean, nonetheless, there are tutorials out there on how to do it. And it's once you get a hold of it, it's not super difficult. But for me, for example, what now has come as well is there's different companies who create different forms of implementations of Bitcoin Core. So there's this company called Umbrel, Umbrel, and they're not financially incentivized to say this. They have no, association with me, but I use their product have been using it for quite some years. And essentially what they did is they created a very friendly way to run a Bitcoin node, where on their website they have a step-to-step guide on how to do it with either a Raspberry Pi or a dedicated computer. And then they actually have a user interface that allows you to interact with the blockchain in a way that's very easy to use. And then they have an app store where you can download the different wallet softwares that connects with the blockchain. And so that's what I recommend for most people. And there will be more, I'm sure there will be more implementations coming in the future, ways to make this more accessible to people. This is really only just the beginning, in my opinion. But right now, that's, the most friendly way, I think, to do it. That's how I do it. That's how I've been doing it for the past, 3 years when I first started running a node. And it works flawlessly, I mean, there's obviously bugs here and there, but for the most part, it works really well. Once you have it set up, you don't really have to do anything else. And it kind of just runs in the background. So because I use a Raspberry Pi, it just syncs in the background. It constantly updates the blockchain. And then I'm able to, through the user interface that I interact with, I'm able to see the blockchain, see my wallets, see all the transactions, all of that good stuff. So that's essentially what you're doing, right? When you're running a full node, you're just downloading a copy of the blockchain and then, using a wallet software to interact with it. And on the background, this is not something you have to do yourself, but your node will verify transactions. It will enforce Bitcoin's consensus rules, and then it will propagate transactions to the entire network. So again, that's a broad overview of how that works. If you are interested in running a Bitcoin node, I highly recommend you, go and search on YouTube for some tutorials. One that I highly recommend is there is a guy, his YouTube channel is called BTC Sessions, and he does great with tutorials, anything from how to run a node, the different wallets, all that good stuff. So if you're interested in running a Bitcoin node, I highly recommend checking that out. So there you have it. That is the overview that I wanted to give today. Again, the purpose of this series is not to go too deep into the weeds of all the technical aspects, more so to give you a broad overview of how everything works and how everything plays a role together to create Bitcoin. And that's what we discussed today, the Bitcoin peer-to-peer network. What are the differences between a peer-to-peer decentralized network and a centralized network like a client-server model? We talked about why Bitcoin is a peer-to-peer network and the importance of that. And we talked about the different nodes, how to run a node, and I hope that all made sense to you guys. I recommend, if anything is a bit confusing, to go back, re-listen a bit, take some time to digest it. Again, I know it's pretty complicated stuff. It's not the easiest, material to understand, but I hope through this podcast that I'm explaining it in a way that's easy to digest and accessible to everybody. And again, I'll continue this series. In future episodes, we'll be diving into more topics such as Bitcoin mining and how that works. But for now, that's this episode. Bitcoin's peer-to-peer network, the amazing innovation that it is. I hope you enjoyed the episode. Thank you so much for listening, and until next time.